Okay, we're continuing with more example problems on functions and relations. For these initial problems, we want to determine the x and y intercepts for the given function. Now note that the idea of finding intercepts is not unique to functions. We can find intercepts of any relation. So any equation, you can think about finding it intercepts of different variables, or even a relation that's just a list of points, ordered pairs, ordered triples, whatever. You can think about finding what the intercepts are of different variables. And the idea is all you're doing, if we're thinking about where graphs of relations intercept axes in a Cartesian coordinate system, if it's not Cartesian coordinate system, then that's a topic for another video. But if it's Cartesian in any number of variables, because you can think about a Cartesian coordinate system abstractly, even if it's more than 3 variables, all you're doing is, so if you're trying to find an intercept of a certain variable, you're setting all the other variables equal to 0 and then solving for that variable that you're trying to find the intercept for. That's it. Okay, now, but if you've got a function, so if we look at this function here, there's no difference as far as how you find the intercepts, but mechanically, it's unique because you've got a function, you've got the output variable on its own over here, so that's why you can replace it with function notation, and then this expression on the other side with all of the other variables. So what that means is that if you're going to be finding, so for the case of 2 variables, x and y, with y being the output, if you're going to be, so let's say you want to get the y-intercept, where the graph intercepts the output axis. Okay, so then that means you set the input variable equal to 0 and solve for the output variable. Well, the output variable is already solved for. That's the nature of how the function equation is set up. So all you're doing in that case, then, since it's already solved for, then you're just, the y-intercept is just the function evaluated at 0. That's it. Now, the x-intercept means that you set y equal to 0, but y is, f of x is, it's already solved for. In that case, you're just solving the equation f of x is equal to 0 for x. That's it. Now, just note that when it comes to x-intercepts, there could be multiple x-intercepts because you can have separate x values corresponding to the same output, but there's only going to be one y-intercept because you can't, it would make sense if it would be a function. You can't have separate y or the same x value mapping to different y values. Okay, now we can extend this to a function in however many variables. And the idea is that, so let's say we've got a function in x, y, z, and w. So total of this equation would have like 5 variables. You've got the input variables, but then, the output, it's a kind of a variable as well. It's the output variable. So if we wanted to find where this function intercepts any of the input variable axes, then the idea is you're wanting to solve the equation, so we can just pick any one of these. Let's say we're trying to find where it intercepts the y-axis. Then you're setting all the other variables equal to 0, as well as the function equal to 0, and then you're solving this equation for y. Okay? Now, if you're trying to find where the graph intercepts the output axis, the function axis, then you're just evaluating this, the function at every single variable equal to 0. That's the idea. Okay, so, but if we're just keeping it simple with 2 variables, what are the x and y intercepts of this function? So the y-intercept, we just evaluate the function at 0, so -4. When the output equals, so it's the y-intercept. It intercepts the output axis here, which means that x has to be equal to 0. I mean, that's the thing, is the point is 0 minus 4. Okay, now if we want to find the x-intercept, we set the y equal to 0 and solve for x. So 2x minus 4 is equal to 0. Add 4 to both sides. Divide both sides by 2. X is equal to 2. So there's the x-intercept. Okay, let's get the y-intercept. So just h of 0, there's going to be one value here. That's minus 8. Okay, the x-intercept, we're just setting the function equal to 0 and solving for x. So the absolute value of x is equal to 8. We know that there's going to be two values here. X is equal to plus or minus 8. So there we go. That's the two. There's two x-intercepts, and there's always going to be one y-intercept for a function. Okay, let's get the y-intercept. So just evaluate the function at 0, at x is equal to 0. There it is. Now the x-intercept, we just solve for, we set the function equal to 0 and solve. So x squared is equal to 12. Square root of both sides, but we need to do the square root property. So x is equal to plus or minus 2 root 3. Okay, let's evaluate this at x is equal to 0. So you have the absolute value of minus 8, which is equal to 8. There's the y-intercept. Now we set this equal to 0, and we just have an absolute value equation here. Well, we know if we have the absolute value of an expression on one side of an equation and 0 on the other side, then the only solution is when the expression equals 0. So there's one answer here. X is equal to 8. Okay, f of 0 is the y-intercept. That's going to be minus 2. Now we solve this radical equation, add 2 to both sides, square both sides, x is equal to 4, but with a radical equation we need to check for extraneous solutions. So principal square root of 4 is 2, 2 minus 2 is 0, so there we go. Okay, we can think about x and y intercepts of functions in actual applications, of course. So if a student decides to finance a used car over a 5-year period after making a down payment of $2,000, the remaining cost of the car, including tax and interest, is $14,820. The amount owed, which is this output y, which they're writing in function notation, a amount owed is a function of time, and dollars is given by this function here, where t is the number of months after purchase, and the domain of t or the function is anything between 0 and 60. Because you're starting at 0, obviously times 0 when you buy the car, but the loan is a 5-year loan. So that's the domain. You can't just input 1,000 years into here, right? Or whatever that will correspond to in months. Okay, determine the t-intercept and y-intercept and interpret their meanings in context. Okay, so the t-intercept, where does this function intercept the t-axis? Well, you set the function equal to 0 and solve for t. So 247t is equal to, okay, so t is equal to, okay, 14,820 divided by 247 is 60. 60 months. And there we go. There's the plot. It intercepts the t-axis at 60. And that's the idea. The amount owed, once the loan is up, if the payments are being made each month, the amount owed is going to be 0. And that makes sense, because at the t-intercept, the amount owed, the output is equal to 0. Okay, what about the y-intercept? Well, in that case, it's a of 0. It's the amount owed at time 0. It's 14,820. That makes sense. That's the amount you're starting with, the loan you're starting with at time 0. Okay, now for these next problems, we want to determine the domain and range of the function. So, okay, what is the domain and range of a function? Well, remember the idea of domain and range it's not unique to functions, just like intercepts aren't unique to functions. Any relation has a domain and range. Any relation, and not just relations in the form of equations, any relation. The domain is all of you're just listing out all of the inputs that if you input them into the relation, you're going to get an output. That's what the domain is. It's all of the sort of acceptable inputs. I don't want to say acceptable because you can still input a number, let's say, and get that's acceptable as an input, but you're just not going to get an output. There's like no solution, you could say. So I don't like saying acceptable, but it's all the inputs that whenever you input it, you're going to get an output. Okay, but then the range is you're listing out all of the potential outputs that you can get. If you input something within the domain of the relation, then the range is what are all the possible outputs you're going to get. All right, now, but we're going to be doing this with functions, though. We're going to focus on functions, determining the domain and range of functions. So this isn't an equation, it's just a list of, it would be 5 ordered pairs here, but that's still, that's a relation, right? It's any list of ordered pairs, but if it's like an infinite number of ordered pairs, then you could put that in the form of an equation or just a description. But here we've got these 5 ordered pairs, not just ordered pairs, any point with any number of dimensions. Okay, so you've got, let's see, this is a function. We can see it passes the vertical line test, but what's the domain? So the domain is the set of numbers minus 3, minus 2, and yeah, you don't list duplicates as well. You don't list, it's all the possible inputs, not including duplicates. And then 2, and then 3. That's all the possible inputs. Now, what's the range? All the possible outputs. Let's see, we've got minus 4, minus 3, 3, 4, and 5. That's the range. Okay, here, this is more of like an equation type situation, where there's an infinite number of ordered pairs here, but we can still list, state what the domain and range is using interval notation. So the domain is, let's see, you can input anything from minus 3 to infinity, not including minus 3. Because we have an open circle here. If you tried to input y of minus 3, there's no output. Okay, the range we can see is anything from 1, including 1, to infinity. You can get any value from 1 to infinity. Okay, here the domain and range is all real numbers. The domain is minus infinity to infinity. The range is minus infinity to infinity. You can see, you can input anything on the x-axis, and you're gonna be able to get anything on the y-axis. Okay, let's see. Here, the domain is you can input anything. You could see. But the range is not going to be less than minus 3. You can get minus 3, but nothing less than minus 3, but anything above minus 3. Okay, here, I'm assuming that the graph, this pattern doesn't just continue to repeat, going all the way down the x-axis. Otherwise, they would have put another one of these. So in that case, then if this is the entire graph, then the domain is, so not including minus 5, all the way to 1, including 1, because you can input any value here, including minus 3. You can input any value here, including minus 1. You can input any value here, including 1. Okay, now the range is tricky, because it's tempting to say, okay, you can get anything from minus 1 to 3. But no, the range is so the set of minus 1, 1, or 3. It's going to be one of those 3 numbers. And you don't put duplicates, even though you can get, there's a lot of different x values where you can get minus 1. You don't put duplicates. The only thing you're going to get, no matter what you input, you can input anything from minus 5 to 1. Not including minus 5, you're going to get one of these 3 numbers, no matter what. So that's the range. Okay, for these problems, we're given functions in the form of equations, and we want to determine the domain of the function, just the domain. Okay, so but why not the range as well? Well, you can think about when it comes to finding the domain of an equation form of a function or even a relation. So with a relation, you might have expressions, different expressions on either side of the equation. All you're needing to do is analyze those expressions to figure out if there's any scenarios where you won't be able to actually simplify the expression down to a number and get a number. If you're able to input some values for the variables and simplify the expression down and get a number, then it's within the domain. Okay, but now the range, though, you could think about with equation form, just equation form, that could be a little more difficult to figure out what are all of the possible outputs. We did that in the previous problems because we had the graph, so we could visually inspect to see what both the domain and the range were. Now, as you progress through this course, and even once you get through calculus, you'll have more skills to where you'll be able to look at an expression like this and figure out what the range is. But right now, we're just starting with let's look at these functions here. So we'll just be having an expression on one side and figure out what the domain is. What are all of the x values we can input, and we'll be able to simplify and get a number. Okay, but now with that, then up to this point, what are the scenarios when it comes to evaluating an expression, simplifying an expression? What are the scenarios where issues come up where we aren't able to simplify the expression? Well, there's only two situations. Up to this point, there's only two situations. One is dividing by 0. You can't divide by 0. The other is a negative number under an even root radical. Okay, but that's it. Everything else, any kind of expression, you're adding, subtracting, multiplying, dividing, exponents, whatever. You could simplify it and get a number, no problem, except for dividing by 0 and a negative under an even root radical. Now, just to give you a preview, for the rest of this course, the only other new expressions we're going to talk about are exponentials. So you have a number to the power x, and logarithms, which is just the reverse, like the inverse process of this, and it's like similar to multiplication and division or inverses. Okay, well, in this, for this kind of expression, you'll be able to input any x you want, no problem. For this kind of expression, x needs to be greater than 0. Now, I do want to point out, though, that once you fully learned complex numbers, so you've gone through, we learn more about complex numbers at the end of trigonometry, but then after that, there's going to be a full complex analysis course. Once you can fully work with complex numbers, then if you want to allow for variables or expressions the variables and expressions to include complex numbers across the board, then in that case, there is no more issue with a negative under any even root radical. Yeah, so like at this point, we could actually, if we had the square root of -4, we could actually simplify this right now. But if we had something like this, we have no clue what to do. Well, once you're done with complex analysis, there's no more, if you want to include complex numbers, there's no more issue with even root radicals and negative numbers. And that's going to be the exact same idea when it comes to logarithms that with inputs that are less than or equal to 0. However, when it comes to dividing by 0, that's still a no-go. It doesn't matter what level of math you get to. In the year 2025, there's no scenario where you're allowed to divide by 0. Okay? Now, but for these problems we're about to work, we're going to assume that we're not allowing for any complex numbers, in which case we're not allowing for any negative numbers inside of even root radicals. That's what we're going to assume for these problems here. So let's determine the domain of each function. All right. So if the only scenarios, since we're not going to be having any logarithms here, is you cannot have a negative number under an even root radical and you can't divide by 0, then that's all we need to look for, unless there happens to be an externally applied domain restriction. So maybe it's a case where x has to be less than 0. That's like the example we saw with the 5-year loan, right? So the only acceptable inputs in terms of months is something from 0 to 5 years. Okay, so you could have an externally applied domain restriction, but if other than that, we're looking for, you can't divide by 0, you can't have a negative number under an even root radical. Well, okay, so in this case, x minus 4 can't be equal to 0. That's it. This denominator can't be equal to 0. Therefore, x can't be equal to negative, or can't be equal to 4. That's it. You can input any x you want. We're just dealing with real numbers here. You can input any x you want as long as it's not equal to 4. Okay, here you just can't divide by 0. That's it. There's no radicals here. There's no external domain restriction applied. X squared plus 2 just can't be equal to 0. Well, there's no real number you can input here, square it, and then add 2 and get 0. So you can input, the domain here is you can input any number you want, any real number you want. So the domain is all real numbers. Okay, now here we have an even root radical, but we also have a denominator of a fraction. So typically you would allow for x, we would say x plus 9 needs to be greater than or equal to 0 for the even root radical, because you can have a 0 under an even root radical. But here we need to say that x plus 9 needs to be greater than 0. So we need to solve this inequality that subtracting 9 from both sides. We see that x needs to be greater than negative 9. That's the domain. You can input any x that's greater than negative 9, and you'll get an output here. Okay, even root radical. That means what's inside the radical needs to be greater than or equal to 0. Let's solve this inequality. T needs to be less than or equal to 16. That's the requirement. That's the acceptable inputs into this function. Okay, you have an odd root radical. There's no denominators. You can input whatever you want. Okay, odd root radical. You can input whatever you want, but there is a denominator here, so the only requirement is that this denominator can't be equal to 0. Well, there's only going to be one case where the fifth principal root of x minus 3 is equal to 0. That's when x minus 3 equals 0. So this just can't be equal to 0. X can't be equal to 3. That's the domain. Any x you want, any real number you want, except for 3. Okay, there's no radicals, no denominators. X can be any real number. Okay, no radicals. We just have this fraction here. This denominator cannot be equal to 0. X cannot be equal to negative 1. That's it. Any number you want except for negative 1. Okay. There's no radicals. It's just the absolute value of x plus 1 minus 4. This denominator here cannot be equal to 0. So let's solve this absolute value equation here. Yeah, I mean, you might say, well, what about the absolute value? No, you can input whatever you want into an absolute value. There's no issues with absolute values where, like, the restrictions come up, right? So, okay. Absolute value of x plus 1 is equal to 4. So we solve this by, so x plus 1 could equal 4. So x could equal 3. X plus 1 could equal minus 4. So x could equal minus 5. And let's see, 3 plus 1 is 4. Minus 5 plus 1 is minus 4. So these are both solutions. So x can't be equal to 3, and x can't be equal to minus 5. But any other number is fine. Okay, you can input whatever you want here. There's no absolute values, have no restrictions. Okay, here x plus 15 just needs to be greater than or equal to 0. You can have a 0 here. X plus 15 could be 0. So x needs to be greater than or equal to negative 15. Okay, here c plus 20 needs to be greater than or equal to 0. So c needs to be greater than or equal to negative 20. Okay, here we have an externally applied domain restriction. So we automatically know that you can't input anything that's less than 0 or greater than or equal to 7. Okay, but maybe there's more restrictions that are part of this domain here. Well, no, 2x plus 1 is just a polynomial. You can input anything you want, but there's this restriction here applied. So that's the domain. Okay, this is just a polynomial. You can input anything you want. Okay, we have this function here. Y is equal to f of x. This is a function. It passes the vertical line test. What's f of minus 2? Well, when x is equal to minus 2, the function is equal to minus 4. What is f of 3? Well, when x is equal to 3, the function is equal to 2. Find all x for which the function equals minus 4. There can be multiple x's that correspond to the same output. That's fine. And we can see there's 2. There's 2. So x is equal to minus 2 and x is equal to 2. Determine the x-intercepts. There can be multiple x-intercepts. Let's see. We've got minus 3.5, 0, and that's it. So, and x is equal to 0. Determine the domain of f. The domain is, it's anything. Minus infinity to infinity. You can input anything you want. But the range is going to be minus 4 to infinity. You might say, well, what about this gap here? Well, no, you can get that. It's just you're just listing out all of the possible outputs. You can keep plugging in any number you want, and you'll be able to at some point find the output you're going to get is going to be you can find any number between minus 4 and infinity. Okay, same problem, but with another function. So what is f of minus 2? We can see that is 0. Okay, what is f of 3? We can see that is 5. Okay, what is all x for which f of x is equal to minus 4? Well, there's 2 values. That's at minus 4 and 0. Okay, determine the x-intercepts. We've got one at x is equal to minus 2 and one at x is equal to, it looks like 1.25. X is equal to 1.25. Okay, what is the domain? Let's see. We've got, you can input minus 4 and then anything above minus 4. If you inputted something over here, you're not going to get a value. Now, what is the range? Let's see. Minus 4 to 5, including 5. That's kind of tricky. You see, it doesn't go past 5. But anything between minus 4 and 5, you can get that value.